You are listening to the Wi-Fi Ninjas podcast, where we talk about wireless technology. Here are your hosts, Mac Daring and Matt Starling.
Hey everyone, welcome to the Wi-Fi Ninjas podcast. Matt and Mac here, and today it is just Matt and Mac here, no one else.
It has been a while.
It has been a while.
How are you doing, man?
Very good, thank you. How are you?
Never better. I'm a little bit excited about this episode because it has been like 10 episodes-ish since we didn't have anyone on the show. Feels weird.
Yeah, I know.
So, what are we going to be talking about today?
Well, today we're actually going to be covering roaming. So we thought it was quite a good subject for me and you to cover by ourselves. So, talking about, what to look out for when roaming, what to design for when roaming, what client devices do, why they roam, how they roam, what we can use to roam faster. And yeah, pretty much everything to do with roaming.
Yeah, so it's a very important topic that we deal with every single day, especially where we work in the carpeted office space. But not only that, even when we do designs for warehouses and we have some AGVs and stuff like that, it's very important for them to roam quickly as well. So some devices, they are designed to roam fast, some are not designed to roam fast. So we'll be talking about what to expect from roaming based on the device's type and the network type as well, the configuration authentication, how that affects roaming, amendments, and stuff like this. So what is roaming? Maybe let's start there.
Sure. Well, roaming is from when a device decides that it's no longer going to stay connected to the access point that it's currently on, and it's going to go and leave and try and find another access point to go and join. So leaving one access point to join another access point is what we would class as roaming.
And the keyword that you said there is a device. Mm-hmm. When it wants, when it joins, blah, blah, blah. So it's the roaming decisions, it's always sitting with a device, right? It's a device's decision. So infrastructure, it can suggest to a device as I want you to roam with like some kind of amendments like 8.11v or something like this. But it's always down to the device to decide if it wants to roam, when it wants to roam, to what new BSSID it wants to roam to. It's a device, always device's choice. So we know that roaming is pretty much the same as the association. So when you connect to the Wi-Fi network initially, you go through the association process and authentication process. So it's like open authentication request response, then you have association request response. If it's open, that's it. Then you can have four-way handshake for PSK. And also before that, you can have .1x authentication for .1x secured Wi-Fi networks. And then when you do roaming without anything enabled, just like out of the box, no amendments enabled, every time you switch to a different AP, you would go through the same process of reassociation, reauthentication, and stuff like that. So it can take some time. But before we go there into what is really happening when you roam, let's say, Matt, that I'm a device. Mm-hmm. And I'm getting nervous. I'm getting like a little bit farther away from the access point, farther than I would like to. I'm hitting my roaming threshold. It will be different for every device. So we'll talk about that in a sec. But I want to roam. I want to start roaming. So I asked all the access points around, hello, anyone out there? And I went through all the channels, like starting at channel 36, 40, blah, 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 went off channel. And I probed, or I listened to beacons on DFS channels. I have answers from 100 different radios. Hello, I'm here. My name is Matt, and I'm your potential new access point. Join me. And I had 100 of these answers. What my device can base a decision on when it comes to choosing the next best BSSID to roam to.
Well, first of all, I mean, you started at channel 36, so what's wrong with 2.4 gigahertz, right? You just decided to skip all of those channels, did you?
Yeah, man. Yeah, of course, I forgot about that. I don't work with 2.4 too often these days.
Yeah, so it's a good point, Mac, is that your device will go through and it will scan or beat all of the available Wi-Fi channels, and like you said, then you get a response from lots and lots of different access points that support the SSID that you want to join to. Why does your device join access point A over access point B? And there's a whole bunch of different reasons why that could be. So we refer to this as like the green diamond process, but my little analogy that I like to use when talking about, or helping people think about, the green diamond process and the association process is that Mac, let's say that you're feeling hungry and you decide to go onto your favorite, food delivery app, something like Deliveroo or Uber Eats or Just Eats or whatever it is. Like, let's say,
Sure.
yeah.
Deliver at my place.
You can't get it where you are. Let's just say you don't live in the middle of nowhere and you can get some of these like luxuries like food delivery to yourself and you fancy a pizza. So let's say you go onto Deliveroo and you just type in the word pizza. All of a sudden you're going to get returned to you a whole bunch of restaurants. So what would be a reason why you would want to, pick a pizza from one of these top restaurants that return back to you?
So my reasons will be different than yours. If you were choosing, you probably would go for the most expensive or for the brand. I would probably go for the first value and then stuff that I really fancy. So maybe I feel like, and now Italians, they will kill me, like a pizza with the pineapple. Alberto loves it a lot.
Hawaiian.
Or I would get Hawaiian because it has ham in it.
True.
So yeah, I will take a look at the ingredients, at the price, at the delivery time, and I will combine all these things together before I make my final choice, of course.
So yes, that's the reason why you would look at it. And like you said, I would go for like a very well-known like vendor. I would look for, probably when I go, like you said, I'd probably go for the more expensive pizza, and I'm looking for, a pizza that will fit my dietary requirements. So I've got a different set of requirements as to why I would choose pizza from Deliveroo compared to yours. And it's the exact same for our Wi-Fi clients. They've got a different algorithm that has a different set of requirements as to why they would join an access point or why they would then roam to another access point. It's all unique to the different devices, and it can also change in a software update. So it can be something just as very simple as what is the strongest signal coming from the access point that returns back to me. Or maybe it gets a little bit more complex and it starts to look at things like how busy is the channels of the access points that have all responded to me. What is the SNR value? Has this access point treated me badly before? Maybe it's hurt my feelings, and I'm not associating to you because you called me a bad name last time. So there's a whole bunch of reasons why one device would connect to an access point over another one, and it changes from devices completely. And also it can depend like what is the environment that you're in. If you look at like iOS devices or like Mac OS devices, and let's say that they hear the same SSID from same SSID on less than 3 access points, the device will think that you're at a home or in like a home environment, and therefore you probably don't want to roam as much as what you would in an enterprise environment. So the characteristics and the reasons could change. Whereas if it hears the SSID coming from more than 3 different access points, you'll think you're in an enterprise space, and therefore, maybe your roaming algorithms and thresholds will be slightly more aggressive because it thinks, oh, maybe I do want to roam a bit more often.
Yeah, that's a really good point. And I think they don't hear the SSIDs; they hear either beacons or probe responses. If you want to be technically correct, there are a bunch of
you got the point, right?
I feel like a bad person.
You are a bad person.
Yeah, I am. Am I not? There are different things that the devices that can look at while making the decision as well. Let's take a look at the iOS devices. I think, let's say that you are actively transmitting data when you want to roam. So you are on a voice conversation and you are getting to your roaming threshold. That is for iOS devices around next 70, I think, seen from the device perspective. And if I am on a voice conversation or any conversation, transaction is happening in Wi-Fi while I'm looking for roaming to a better access point, it will look for an alternative that is just 8 dBm better than my current connection. So if I'm getting close to like next 72, if my device finds a BSSID with the RSSI of neg 64 or higher, it will just jump to that straight.
Do you mean beacon or probe request then?
Yes. On the other hand, if you are not transmitting any data, so the device is pretty much idle but still associated, active in the network but not actively transmitting, it will look for a connection that is better by at least 12 dBs, for example. So it can also affect the device's decision. And as you said, some more sophisticated devices, like, for example, Apple devices, especially iOS, they will take a peek into BSS field in the beacon to take a look into channel utilization, number of associated stations, so they can make more educated decisions when it comes to choosing their next best AP. How many people, Matt, work for Apple making these algorithms?
Well, I don't know. I mean, rumor has it there's at least 100 people working on this algorithm, but whether that's true or not, I don't know. But I'm sure there's probably quite a lot of people at Apple looking into this when compared to maybe like a cheap IoT device that's got, you know, very simple algorithm where, like you said, it's just looking for the strongest signal for the strongest RSSI from the beacon or the probe request.
Yeah, and the other very popular attribute that the device can choose is, on top of the RSSI, strongest one is the which access point responded first. So I've seen it quite a lot. Like when let's say you have your survey device that is not designed for roaming. So let's say you are doing validation surveys with a laptop, like a cheap laptop that doesn't have a sophisticated algorithm, Green Diamond algorithm running on it, a crap firmware, bad Wi-Fi quality, bad card in it. You won't be connecting necessarily to the strongest AP when you walk next to it. You might be connecting to the access point that is 30 meters away, but it's still good enough for your device. And this was the first AP that it has discovered. So it depends on the device. Okay, so I think that's enough when it comes to Green Diamond and decision making when it comes to roaming. So to get the responses from the access point, there are two possibilities. One possibility is for the device to wait for beacons. Beacons are being sent 10 times per second per SSID, per radio, kind of every 102.4 milliseconds. That's a target time where the beacon is being sent. So if a device wants to wait for a beacon, typically it will spend around 105-ish milliseconds on every channel, aiming to get at least one beacon so it knows what's alive on that channel. And if you don't have this 105 milliseconds to dwell on each channel, sitting off channel while, let's say, you are being on a voice conversation, you can send a probe request. But we have to be careful there because you cannot send a probe request on every channel. You can send probe requests on just non-DFS channels. We won't dive too deep into what the DFS is. It's a radar activity. It's a discussion for an entire different podcast. But you have in Europe just 4 non-DFS channels, 36, 40, 44, and 48, Uni 1. In States, you have 9. You have Uni 1, so the same channels as in Europe. Plus, you have 5 channels in Uni 3 that are also considered non-DFS. And you can just probe on these channels. All the other channels in between, so all the DFS channels, you have to wait for a beacon. So DFS channels, if you don't use any amendments, they will slow your roaming down. If you are relying solely on DFS channels, you will see slower roaming, assuming that you do not use roaming amendments. That's one thing. We'll talk about roaming amendments in a second. And another thing, the roaming thresholds, they can be wildly different per device. When you have your iOS devices and they have a roaming threshold of next 70 from their perspective, okay? If you have 2 iOS devices, even the same iPhones or the same iPads, same models, they will see the RSSI differently. They are not calibrated devices. So it can be next 70 for Matt's iPad, and it can be already next 73 for mine. And it's normal. On the other hand, when you have like a Mac OS devices, laptops, big guys, they are not expected to roam as quickly and efficiently. They are not. So they are designed for you to open a lead on the desk, connect to the best available access point at this moment. If you want to move your laptop to a meeting room, you are not like getting onto a conference call while sitting at your desk and then you disconnect your laptop and then walk with a massive laptop, or even if it's ultra portable, it's still not that portable. Open laptop through a floor to get to a meeting room. You don't do that typically. You close the lid, you take a laptop to where you want to go, you open the lid again, and it will reconnect to best access point in a new place. So these devices, the big laptops, Mac OS devices, they are not designed to roam quickly. Why is it so important to me? I've spent like 3 days trying to troubleshoot roaming issues for laptops in a wireless first environment for one of my clients a few years ago. And I've concluded through multiple chats with Microsoft, with Apple, with Cisco, that it's just how it should work. It's going to be slow, and we should set our expectations correctly. That we got.
One thing that I like to point out to some of the clients and people that when we're talking about roaming is that a device doesn't actually have to physically move to roam to one access to roam from one access point to another. There can just be a change in the physical environment. Let's say you're sitting down at your desk in the office, and all of a sudden, lunchtime comes and 6 people decide they're all going to get up at the same time, and then they're going to leave to go to lunch, and they decide to walk between your laptop and the access point. You've now got 6 people, let's all say their max size. That's going to really heavily attenuate the Wi-Fi. So that's going to pretty much have a big impact change on the RSSI value from your device's perspective as everyone goes to lunch. If I was to walk past like 6 people my size, the device probably wouldn't even notice. But that could be that's a change in the RSSI. It might drop below the threshold for the device thinking, I need to now go and roam to another access point. But you could be sat there in the middle of a video call, like a video Teams, WebEx, Zoom, Blue Jeans, whatever system it is you use for video conferencing calls, and then all of a sudden your device is not physically moved, but it's had a change in its RF environment. It's like, I need to go find another access point. And like you said, Mac, if you've not got any fast roaming amendments enabled on your SSID, and let's say it's a corporate laptop, so there's a good chance you're connected to the corporate SSID, and if it's a corporate SSID, there's a good chance it's using .1x authentication. And let's say now your device has to go and do a full .1x, roam to another access point, and you haven't got something like 802.11r enabled, that could take a really long time in Wi-Fi anyway. So if you're sat there on a video call and your device roams from an access point to another access point with no 11R, if you're on a video call, your experience will be you might lose your video, your voice will become choppy, or you might get completely disconnected.
Yeah, that's a very good point, man. So since you mentioned the amendments, let's jump straight there. Mm-hmm. What is 802.11r? What is it?
So 802.11r is also known as fast transition, and this is a hugely important amendment for, especially if you're using any .1x radius authenticated SSIDs, because what this does basically, let's say your device first connects to an access point that's using .1x, it's going to have your client device will have to associate to the access point, go through open system authentication. Once your device has done that, and you're going to start doing the security checks, what happens is that your device is going to go to the access point. You've got some credentials that's going to be, need to be checked against an Active Directory server or something like that. So your access point has to forward on your client device details, maybe through the controller, if you've got a controller, or if not, it's going to go through your radio server. Your radio server is then going to check your credentials against an Active Directory. And then, it's all got to come back. So there's a lot that goes on over the air, which, for that first initial radius authenticated session to get authenticated could take, depending on where your radius server is, anywhere up to 400 milliseconds to maybe even longer, like 800 milliseconds, which doesn't sound like a long time, but in Wi-Fi, that's a hell of a long time.
And I think you're being quite not conservative enough there. I've seen like way longer authentication times, they 800 milliseconds sometimes, because you can have a radius in another continent, and then you can have your AD or employees database, whatever else, somewhere else in another continent, and it goes back and forth until your device is authenticated. And it's really a complicated process, right? Because you not only have to go through the association, open authentication, stuff like this, four-way handshake at the end, but this .1x process, it takes time.
Yep, it does take time. And if you haven't got 11R fast transition enabled on the SSID, each time your client device roams from one access point to another access point, it's going to have to go through that full radius authentication each time. And like Max said, maybe I was being a little bit too conservative. It could take way longer than 800 milliseconds. And if you have a delay of anything over 150 milliseconds whilst you're on a voice or a video call, you're going to notice like jitter, stuttering or quality drops basically. So
yeah, and that's entirely the case. So with 802.11r, the aim is so we do not have to go through the full reassociation, reauthentication every time we roam. There are 2 flavors of 802.11r that we'll talk about in a sec in more detail. It's over the air and over the distribution system. But long story short is, if your device supports 802.11r and it's enabled in your SSID, you will not have to go through full reauthentication against the backend servers every time you roam. And that being said, it will massively speed up your roaming process. So it's extremely powerful and important feature. So how it really works, like from a back-end perspective, is that when your device goes through the initial authentication against the radio server, let's say, it will get a master session key. It's the MSK. And this MSK will be used to derive like two different keys. Let's not dive too deep, but you will have PMK R0 that is being put on the authenticator. So it can be a wireless LAN controller, or the access point, typically a wireless LAN controller. And then the same key is going to be derived on the from the MSK on the client supplicant itself as well. And then the devices that they hold the PMK R0 key are going to derive PMK R1 key that is in turn being used to calculate a PTK. And PTK will be calculated on both access point and the supplicant, so our client. And when we have the PTK, we will use that to negotiate our keys as part of the four-way handshake to get the encryption keys that we will use to encrypt unicast traffic and broadcast traffic. Different keys are used to do that. And that's a hell of a lot of things to do when you think about doing it every time you roam between the APs. If you walk around the office that is designed correctly, then you will be doing a full re-authentication like every several seconds. So that's probably not something that you would like to see. And if you have 802.11r enabled, the MSK is being sent to all the access points that are being part of a system, Wi-Fi system. And therefore, the device, every time it wants to reassociate, so roam, it will not have to go through the full re-authentication. It will just have to do a four-way handshake. And inside the four-way handshake, you will have maybe a different set of frames a little bit than you would have had if you didn't have FT, the fast transition 802.11r enabled, but it will just do that four-way handshake, and that's quite quick. So the most important thing now with 802.11r enabled is to be able to discover your next best BSSIDs as quickly as possible, because now when you know what you want to roam to exactly, so I'm coming from access point A, I have discovered access points B, C, and D, and out of these three APs, my device has decided to reassociate roam to AP D. How do I discover these APs? Because when I want to join this access point, the new AP, it will be fast with 802.11r enabled. It's pretty much as fast as the PSK reassociation, where four-way handshake is all it takes now. So Matt, how do I discover my next APs? We went through the Green Diamond, but going off channel to scan all the possibilities, it will take a long time. So can we speed that up a little bit?
Yep, absolutely we can. And it's another amendment that's called 802.11k or neighbor reports. So what that means is that the access point, say you've got your infrastructure in place, you've got AP 1, 2, 3, 4, 5. AP1 can easily hear access point 2, 3, 4, and 5, and it can see what channels these access points are being that they're using. So what the access point now can it can inform your client device to say, hey, rather than having to go scan all of the channels, I can hear my next best neighbors on channel X, Y, and Z. So your client device now, rather than having to go off channel scan every single one of those channels, it can go, just to those specific channels, which can really, really speed up your roaming times. But I just wanted to go back to 802.11r because obviously we're saying, if you've got a radius authenticated SSID, it's really important that we enable this amendment. But there are some caveats here that if your client device does not support 802.11r and you have it enabled, then your device will most likely not be able to associate to the SSID. So it's really important that you understand what your client's capabilities are before you go and blindly turn on these amendments that is going to make roaming much faster. And depending on what vendor you work on, they may call this different things and might have you enable different ways of turning this on. Like in the Cisco world, you can have it enabled, adaptive, or disabled. So what is the difference between having it enabled compared to adaptive? Well, if you have it just enabled, it means that every device that's trying to associate to this SSID has to support 11R to be able to connect, and you've got to use 11R. But let's say you decide to use adaptive rather than enabled. Well, what does that mean? Well, originally this was more for just the Apple mobile devices. So if a Apple device came along, mobile device, and it supported 802.11r, it would connect and it would use 11R, but any other device, it wouldn't. But I think now in more recent updates, Android also support adaptive connecting to the SSID if it's got 11R adaptive turned on. I'm not sure if there's any other mobile devices now, maybe like Windows, or not sure if there's any other devices that support this, but mainly this was for, first of all, mobile Apple devices, and then mobile Android devices. If there are any more, maybe, not 100% sure. So just really, really important that you check to make sure that your device supports 11R before you enable it, because if you've got like a Windows laptop, like corporate laptop, and it tries to connect to the SSID and 11R is enabled, but the laptop doesn't support it, you're probably going to be getting a lot of support calls or help desk tickets to say, hey, Wi-Fi sucks, can't connect anymore, what have you done?
Yeah, so in most of these devices, you will not be able to connect to your Wi-Fi at all, right? When you have 802.11r enabled, like totally enabled. Have in mind that some devices, they will say that they do support 802.11r, like let's say macOS devices, so they will associate nicely. It's going to work from a client's perspective, but in fact, they are not doing 802.11r, so they will go through full reassociation every time they roam. So that's another reason why it is slow. Okay, so since we are discussing the capabilities and we want to understand if the device supports 802.11r or not before enabling it, how can we check if our corporate devices are compatible with 802.11r?
Yeah, that's a great question. And usually sometimes you can check like the data sheet and the spec sheet of the device, and it will tell you what amendments it supports. So fast transition is also referred to as 802.11r. So like recently I was looking up the capabilities of like a Honeywell CT40 scanner, and I went onto the data sheet and I could see that it has the technology, that the Wi-Fi standard that it supports, and also it told you that it supports 802.11r, 802.11k. But there was one more which we haven't spoken about yet, which is 802.11v, which is fast BSS transition, which we'll come to in a little bit. But I didn't see anything in there for 802.11v, so I was quite curious. So, what does this device support this or not? It doesn't say on the data sheet, but maybe it does. That was great. That was the scanner had that information. But I've also looked up things like Windows, Lenovo laptops, and you look at the data sheet and it just says it supports Wi-Fi. Really like limited information. And the other thing that you don't sometimes see
up to 1.3 gigs.
yeah, exactly. And then the other things that you don't see in the data sheets is actually what channels does this device support. Does this channel support channel 144? Does it support some of these other channels and stuff? So you don't see that. So what you need to do is there's a couple of ways you can do it really, but first way that we'll talk about is that you're capturing the association request via a wireless packet capture of the device trying to associate to the network. So you'd set up your wireless packet capturing device if you're using your Sidekick, your inbuilt wireless card on your Mac, or if you're using like a WLAN Pi or whatever it is you're using to do your wireless packet capture. You would look at the channel that your access point is using, start a packet capture on that channel, and then what you want to do is make sure the client device isn't associated to the access point, and then connect the client device to the access point. And during that process, the client device you should capture the association request. And inside of the association request, that's where we're going to see the tagged capabilities of what the device can support. So everything like the channels that the device can support how many spatial streams, and also the amendments that the device supports. So things like 802.11r, K, and V, which we've spent some time before the podcast today actually doing a couple of packet captures, so we can include this in the show notes and show you exactly where you need to look through, because you can't just go into like say Wireshark and then look for 802.11r K and V. It's going to be called something else, and understanding where you would see that is quite important. So we've done that. We've got the packet captures, so I'll put it into the show notes so you can go onto our website and look to see exactly where you need to go and look through to see what your client device can support, because it can be really helpful, especially even just looking at the channels. Because if your client device doesn't support some of the DFS channels, and then, some of your access points in a bunch have got, these DFS channels on 4 of these access points, your client device just isn't going to see those access points. So the coverage in those areas for that device specifically is going to be really bad. It's just not going to see the Wi-Fi. So that's a big thing that can impact the roaming. Also, you can see if it supports things like neighbor reports and fast BSS transition. So if it doesn't support it, maybe you don't need to have that turned on the SSID.
Exactly, because if you have more bells and whistles turned on, it will probably increase the airtime utilization as well. I probably wouldn't be worried about that too much, but the compatibility can be the killing factor.
Mm-hmm. And you can see sometimes it's good to understand how many spatial streams the client device is capable of, because that can really impact the performance of a device.
Yeah, so less spatial streams, it means that device will have less radios and antennas, and it will not be able just to talk as fast as the devices with more spatial streams. So they'll be spending more time using airtime. Mm-hmm. And if you have just like one spatial stream device, you will have to get that into consideration while designing for capacity for these particular devices, depending on what they do. Typically, however, if you have such a crappy device with just one spatial stream, there will be, in most cases, like barcode scanners, so devices that do not require too much capacity, but not necessarily. So be careful.
So like the CT40 scanners, it doesn't tell you on the data sheet. We'll include the data sheet of this scanner as well, so you can see where it tells you in the data sheet and then what we found in the packet capture. But yeah, this CT40 scanner is just a one spatial stream capable device. So one transmit radio, one receive radio, one spatial stream. Another really, really good way of seeing what your client device is actually capable of is if you have got a WLAN PI. If you have a WLAN PI, there is a piece of software running on the WLAN PI which is called the Profiler. And now this is a really great feature of the WLAN PI, because what it will basically do is it will spin up like a fake SSID and a pre-shared key for you to connect to. And then what you do is you connect, say, CT40, an iPhone, whatever device it is you want to know, what you want to get an understanding of what this device supports. When you connect this client device to the WLAN PI's SSID, you put in the pre-shared key password, you won't really connect or go anywhere. But what the WLAN PI does for you is it captures this information. You can then go to the GUI of the WLAN PI, and really nicely in a little text file, you can see exactly what that client device supports. So it tells you if it supports 11K, 11R, 11V. It tells you what is the minimum transmit power, the maximum transmit power this client device is capable of, what channels that it supports, and what country code. So there's just a couple of really nice ways there for you to be able to see what your client device is capable of. And it's really, really important that you know what your client devices are capable of.
Yeah, exactly. But you need to have WLAN PI for that, and it translates the association request hidden information there. Well, not really hidden, but it's not self-explanatory to us humans into a very nice. It's not a chart; it's like a text. It just says 802.11r V or K, so it's easy to understand.
Yeah,
but
we'll
if you
include
don't
it in the show notes so you can see it.
So that's the thing. I always forget to add these images to the show notes. So
I'll make sure you do it. I'll make sure. Don't worry. And yeah, guys, if you go look and it's not there, then we can all go blame Mac
or Matt for asking me to do it, knowing that I always forget. Since we are discussing it already, guys, if you want to take a look at 802.11r capabilities of your client to see if it is enabled or not, capture the association request, okay, and you just do it by trying to connect to a Wi-Fi network. It doesn't have to be a successful connection. You just have to try. So for as long as you see the association request, you're good. And inside the association request, you might want to filter that in the Wireshark. For that, if you Google SemFio networks wireless, not wireless, Wireshark filters, you have it from Francois.
It's also on our website as well. We've got lots of Wireshark filters there, but we can just put the specific. We'll put the subtype filter that you need as well in our show notes. Matt, come on, let's help everyone out. They can just go to one place to find all this information.
It's like when you're driving a car, you don't go to show notes, are you?
Maybe.
Yeah.
All
so
right.
you can, let's say where you can find it. You can find it in the RSN information.
Yes.
Okay. And then you have RSN capabilities. And no. You have RSN information, AUF key management, and then you will be able to see if you have FT over IEEE 802.1x support or not. So RSN, AUF key management.
Yeah, Mac, what is the, just very quickly, what is the difference between over the DS and over the air?
Yeah, I'm glad you asked because we skipped that part, haven't we? So by default, out of the box, most vendors, they will be set to over the air, I think. But you have like a checkbox or something that you can convert to over the DS. So if you do fast transition over the air, it means that the reassociation, even though it doesn't have to go through the radius authentication again, but it will be done over the air, which means that when you are connected to the access point, let's say on channel 36, and you want to roam to channel 48, BSSID from different AP, then all the FT authentication request and response will be exchanged over the air. And after that, you will go through reassociation request and reassociation response also over the air. So there are 4 frames being sent over the air. And these frames, they are slightly different than standard 4-way handshake, but they do include 4-way handshake in them. So you still have 4 frames, similarly to what you would have had in PSK, and then you are reassociated using FT over the air, but you have to go off channel to send these 4 frames. Okay, so that can affect your connectivity when you are on a voice call, for example, because you have to go off channel from channel 36 to 48 to send a frame, wait for response, send another frame, wait for response, and then you are associated to the next AP. But you might have heard a crack or something. Probably we won't, but it can take some milliseconds, okay? And now when you take a look at the over the DS, which means fast transition over the distribution system, so not all the frames, you still require to have 4 frames exchange that will get the 4-way handshake in it. But first 2 frames, the action frames, the fast transition request and response, they are being sent to a new AP through an existing access point. So you don't have to go off channel. So when I want to talk to the AP on channel 48, I will send the FT fast transition request action frame to my existing access point, and then it will go over the cable, over the distribution system to my next access point. And then after this next access point comes back to me, using my existing AP, I will then just send 2 frames over the air, reassociation request and reassociation response from my station to a new AP. So instead of 4 frames over the air, I'm sending now 2 frames over the air. So that is the main difference. I cannot remember which one was more efficient. I think we had a chat with Peter about that. He was doing quite a lot of tests.
And
do you remember?
I think it was quite, basically it was a little bit inconclusive, and it said that either way it's going to be extremely fast. So don't worry about whichever one you go for. I think off the top of my head, over the air is slightly faster, but I mean, it's extremely minimal. So I think whichever one you choose, it's going to be good. So I wouldn't worry too much.
There you go. So that's the DS versus over the.
So I feel like it's time we talk about the most cheeky fast roaming amendment, which we haven't spoken about yet. I think it's cheeky, 802.11v, right? Because 802.11v tries to take the decision back from the Wi-Fi client device. So 802.11v tries to take the roaming decision back towards the infrastructure. So the access point can say, hey, actually, you know what? I think your signal strength isn't that good. Maybe I'm going to send you a disassociation frame and get you to move to another access point. But, you know, some people don't like being told what to do. Some people like to keep that power and decision of when they want to roam to another access point theirs, not be told what to do by the infrastructure. So, yeah, I think this is the most cheeky Wi-Fi fast roaming amendment, in my opinion.
Yeah, I don't think we have experienced massive issues with 802.11v first hand, but as you said, it works like this. Like the infrastructure tells your client, Mr. Client, I suggest you go to a better access point, and then probably your client is going to ignore it. Then the infrastructure will repeat that again. Go to my friend. It will be ignored. And then the third time it will say, go to my friend, or if you don't, then the authentication or the association imminent, you have 100 milliseconds to go. Otherwise, I'm going to kick your butt out. And most clients, they will not understand it, or they will still ignore it. So they will be hard disconnected from Wi-Fi. And if that happens a few times, some devices, not looking far, iPhones, they might blacklist the SSID. If they are being kicked off from the network, then they connect back. They're kicked off from the network, they connect back, and then they are blacklisting this SSID. So they won't even try to not even try connecting back. I think we had a good presentation from Andrew McHale.
McFly. McHale. Yeah, Andrew from the WLPC in Prague, I believe it was 2019. He done some tests with just turning on just one amendment at a time, and it looks at the roaming times of the device. So I think he just turned on 11R, did some roaming tests, then turned off 11R, turned on 11K, did some tests, turned off 11K, turned on 11V, and done some tests. I'm not sure he did it with all of them combined and turned on, because that would have been probably quite an interesting one. But I know he was having some issues with getting the device to roam between his house, so I had to come up with I don't know if he stuck like a bin over the access point or what he done to get the device to...
That's what I'm good at, like standing in between your client and the access point to force roaming.
Also roam, yeah. So they're the fast roaming amendments. Should we just like recap about what we should and shouldn't do with turning on these fast roam amendments? And let's just say, for example, you're spinning, I'm your customer, Mac. I'm like, hey, come and install Wi-Fi infrastructure for me. What would you do to configure the SSIDs from, let's say you've got a corporate perspective? I want to use radius authentication. How would you set up your SSID?
Yeah, extremely good question. So this is the type of thing that we have to think about every day, right? Because you're probably doing some integrations of Wi-Fi networks, or thinking about doing integrations of the Wi-Fi networks. So if you do have a backend authentication using the radius server, so 802.1x type authentication, then you really want to enable 802.11r. So for every .1x SSID, you want to have .1r enabled. If you have clients that don't support 802.11r fast transition, then bin that client, donate them to charity and buy proper ones. Typically these days, it's not a problem in enterprise environment. All the new clients, even old clients that are not extremely old, so 10 years plus, they should support 802.1r. And I mean it, like all of them. If they don't, bin them.
802.11r. That I think you're getting confused with .1x there.
Yeah, 802.11r. So always have that enabled. Check the capabilities of the clients if you're not sure, especially in like more of the industrial or warehouse environments where you don't have just, Apples and HPs and Dells and Lenovo's, because these are all good. If you have some handheld scanners that you've never heard of or something like that, like some robots, AGVs, then make sure that they do support 802.11r, assuming that you do .1x authentication on the SSIDs for these devices, because typically if you are in that industrial environment and if it's just the IT team setting these devices up, I probably wouldn't try to overcomplicate stuff with .1x, and I would just use PSK. There is no right or wrongs. Your InfoSec team might say otherwise, but be careful there with 802.11r on .1x APs. If you have PSK based authentication, so a personal, like WPA2 or WPA3 these days, personal, then you don't need to have 802.11r. In fact, I wouldn't do it at all, because it will give you no benefit pretty much, and it can add some complexity. Same with open. You don't need to have 802.11r there, because there is no backend authentication. Now 802.11k, so neighbor list, extremely important amendment for fast roaming. So you discover your APs faster, because your existing AP will tell you about its neighbors. Your next three options are this, and this channel, and you don't have to scan 39 channels. You just scan 3 instead. So it's blazing fast. Enable 802.11k for all the SSIDs, open, personal /PSK, .1x/enterprise. All of them will benefit from having 802.11k enabled. I know you're smiling, yeah. .1 always in my head.
So many things to remember, and it's hard to sometimes get them all right. But we know what you meant. Don't worry.
And finally, you have 802.11v, and also the default behavior from all the vendors that we work on is that it's enabled by default. So I probably wouldn't disable it. I would look at it if we have some issues in our network. If we don't, I would just leave it enabled for all the SSIDs. It can be helpful. It can be harmful. Some vendors even, they won't let you disable 802.11v without disabling 802.11k. So you might have something called like a roaming optimization tick box, and then it will combine V and K, for example. So it depends on the vendor. And that's the best practices when it comes to the amendments, enablement on the SSIDs based on the SSID authentication.
So I just want to give one little tip here that I've been doing recently for the customers that I've been deploying Wi-Fi for is that what I suggest to them is that we create, let's say we're creating a Wi-Fi Ninjas corporate SSID. This Wi-Fi Ninjas corporate SSID that's .1x authenticated, I'm going to make this to be a all bells and whistles SSID. So what I mean by that is that this SSID is going to be 5 gigahertz only. We're going to enable all of the available 5 gigahertz channels. We're going to have we've got radius authentication, so I'm going to turn on 11R and have it enabled. I'm going to turn on 11K, 11V and have it all enabled. But then what I'm going to do as a precaution, in case there are some legacy devices in the network that the customer isn't aware of, and it comes to the cut over day and you turn on this SID, they turn up, they try and connect to this SSID and they can't connect. So what I do for my customers now is I create a second version of the SSID, and I'll just call it like Wi-Fi Ninjas Legacy or something at the end of it. But now I'm not going to be making this my bells and whistles SSID. This is going to be what we like to call a very vanilla SSID. So maybe make this 2.4 gigahertz only. Maybe make this and turn off, if you're still using radius authentication, have no 11R enabled. The only one I would also disable 11V, and then the only one that I'd have enabled would be 11K. 11K is probably the safest amendment that you can have on, that shouldn't have any compatibility issues with any of the devices that you connect to the SSID. But 11R, we know, if the device doesn't support it, they're going to have some issues. 11V is trying to take the control back from the client device to the infrastructure, and some client devices, they don't like having that disassociation imminent coming to them. So create 2 versions of the SSID, so when it gets to the cut over day or the day of the new implementation, hopefully 90% plus of the devices, they're able to connect to the bells and whistles SSID that's got everything turned on. Any client devices that are having some issues, then you just put them onto the legacy SSID. They can still connect, but it's not going to impact, or it's not going to punish your good Wi-Fi clients by trying to support all of your old legacy clients. So that's one of the best tips I think I could give any of the listeners that deploying Wi-Fi at the moment.
And that's an amazing tip, man. What I tend to do with this legacy SSIDs that I propose from day one, typically, is I consider hiding them as well. So hiding is not a security feature. It's just the stuff that a typical normal client, when they have a choice to which SSID to connect to, they shouldn't have to think about it. Even if they see like a Corp SSID or Corp Legacy, they probably won't connect to Corp Legacy, but some clients, they will just, click the first one that appears on the list, and it might be 2.4 Corp Legacy. They will just connect to that. So if it's hidden, they will go to the IT support and they will ask, oh, I don't see Wi-Fi. And then, let me connect you manually to the Wi-Fi network using a legacy SSID. So that can work. You have mentioned few very important things that I forgot about all of them. One thing that has stayed in my head is the channel planning. You said that using all the channels, blah, blah, blah. And yes, for roaming, if you want to have really the fastest roaming experience possible, try to use a non-DFS channel, then have like a DFS channel, like 1 or 2 channels in between on the route where your client goes through. Then put non-DFS channel again, like probably from Uni 1 in Europe, then 1 or 2 DFS channels. So let's say channel 36, then channel 100, 104, or 100 and 108 to have a bigger channel separation, then channel 40 and this kind of stuff. In case you have clients that do not use 802.11k efficiently, they will still be able to find the non-DFS channels faster by probing on these channels, and therefore you are increasing your chances of fast roaming. And I remembered another thing. You said that 802.11k is the safest one, and yes, even if the device doesn't support it, it will still not care about 802.11k because this information is not included in any Wi-Fi transmissions before the client asks for it. So client must ask the access point, Mr. Access Point, is a special action frame. Send me details about your neighbors that are going to be my best options for me when I roam. It has to come from a client. So if it client doesn't ask, then the access point doesn't tell. So that's why it's safe. Okay, any other configuration tips when it comes to roaming design?
Try not to have your access points on maximum transmit power. Try and keep the cell sizes of your access points controlled, because if you've got really wild uncontrolled cell sizes, it means your access points are blasting, covering a huge area, and your client device will be able to be heard by the access point from really far away, and it might decide to stay connected to this access point rather than transitioning to another access point. So tip here is to use the physical environment to your advantage to shape the cell sizes of your access points and to use a controlled transmit power. So typically you want to be trying to match the maximum transmit power of your client devices. So access points have got bigger radios, they'll be able to transmit in most cases stronger than your client devices, and your client devices have got little radios and probably can't transmit as strongly as your access point. So that would be my tip for the configuration of the access points.
Yeah, good tip, man. And the typical values that we use, like for 5 gigahertz, that matches the transmitting power levels and sensitivity of most of the Wi-Fi devices out there, especially used in the carpeted office spaces, is around 10 to 14 dBm. So around 25 milliwatts. And that's actually the defaults in the software that we all use and love, where we use Ekahau. Mm-hmm. So you open it up and put a simulated AP there. That's the default power levels these days. And these are good power levels. And then that's for 5 gigs. If you want to have both 2.4 and 5 gig, make sure that 2.4 is always a little bit below when it comes to the RSSI received from your client's perspective. So it must be sitting at least 6 dBm lower when it comes to transmitting power levels than 5 gigs. So if you had like 14 on 5 gigs, make it at least 8 or lower on 2.4. I used to give APs some wiggle room when it comes to setting up transmitting power levels, but I start to grow into a conclusion where I don't like that anymore. I think I would just set like a static 10 or 12 or 14 dBm for every single AP, and I would leave it at that. Because if I give it a wiggle room of between 10 and 14, then I would need to keep 2.4 gigahertz at less than 4 dBm, assuming that I am using 2.4. So if I'm using both 2.4 and 5, I probably would keep it static. If I'm using just 5, I would give it a little bit of a wiggle room between like 10 to 14 dBm kind, stuff like this. Data rates, another thing. Mm-hmm. In carpeted office space, what do you use, Matt?
I think in a standard density, you can never go wrong with just using 12 megabits as the minimum mandatory basic rate. But if you've got a high density environment, or maybe some areas have got bits like higher density, then you can bump it up to 24 megabits per second. We have seen client devices have issues if you set the minimum basic rate at 18 meg. So I think either go with 12 or 24, but definitely disable everything below that, especially if you're using 2.4 gigahertz.
Yeah, exactly. And also when you're doing a design. So I think that concludes the configuration, right? It's like as easy as that. The most important thing that I wanted just to say here is that you cannot fix a bad design with good configuration. So configuration should always be good. But if you are also working on a design for this particular fast roaming, good quality corporate voice and video enabled Wi-Fi network, then another good tip is to not only use omnidirectional antennas built into your APs, not all the time. Not all the time. Sometimes you want to have, if you don't have any obstacles like attenuating materials in between the APs and you have just vast open spaces, stuff like that, and very high density, it will be impossible to provide your clients with wireless first, no cables, ultra high density environment with just Wi-Fi today. It's not going to work, okay? So you might want to start reverting to directional antennas And typical approach in the carpeted office spaces would be to use patch antennas, suspend them down to like as low as possible, and point them directly down, creating a cone of coverage from a ceiling. And therefore, you will not be blasting across entire like 100 meters wide floor with every single AP you want. So your roaming boundaries will be better defined. Your cell sizes will be smaller. So how I like to think about that, if you have low-ish density in open space, carpeted office space, omnis, fine. Like every 15 to 20 meters having an omnidirectional AP, it's an educated guess, guys. It will be different for every environment, but typically that's a good distance between the APs. If you have higher density than that, and if you require more radios, like more radios that omnis like every 10 to 12 meters would give you, then you have to revert to directional APs. Otherwise, you will have mad CCI, channel contention, channel interference, channel overlapping, cross-channel interference. I think that's what CCI stands for. So you can achieve just as much with omnis, especially when it comes to fast roaming and great performing Wi-Fi networks. If you need to have more performance, fast roaming, controlled cell sizes, ultra high density. I know it sounds a little bit heavy on marketing, but ultra high density networks, then you have to use or consider using directionals like 6 to 8 dBi gain patch antennas are typically the way to go.
Very
secondary coverage, right? So you don't only design for primary one, you need to have secondary coverage as well. So every time when your device drops to a threshold, roaming threshold from one AP, it will have to have a secondary AP that has a good RSSI for that device to roam to. And I think that's it from me. Do you have anything to add, Matt?
No, I think it's very, very good tips. I'd say like another thing is obviously when you're looking at using the DFS channels is making sure your client devices support those channels. And a really good website, sorry if you picked up a siren in the background there, dodgy area that I live in. And a really good tip, a website to go to is clients.mycarbana.com, and there's a whole, I think there's about 200 to 300 devices there that tells you the capabilities of the devices from the channels it can use, and I think about the spatial streams and stuff. So yeah, just a really, really handy website. So most likely is that the your device is on there, but if not, then yeah, you can have it put up there as well if you request it, and the PCAP is there as well, so you can actually go through the packet capture and look at the frames yourself.
If you have trust issues.
So,
yeah, I think that's everything that we had on our list for today.
Yep. So just a reminder again, Mac, make sure you include all of the packet capture stuff in the show notes, so everyone can find all of the information that we've been talking about and visualize it, because I think it's really helpful. Really helpful.
Yeah, challenge accepted. I don't think I've included anything in a show note for the last 1.5 years. So let's do it.
All right. Well, thank you very much for your time today, Mac. It was lovely to record a podcast, just me and you again.
Yeah, it was amazing. Let's do it more often, man.
Yeah, I suppose we should. Okay, well, thank you very much, everyone. Hope you enjoyed the podcast on roaming, and we will see you back in a couple of weeks' time.
Thanks a lot. Take care. Bye.